Hi there, in this video we're going to learn how to solve problems on Newton's laws. So here is a typical Newton's laws problem. The question is asking us to write the force equations for this system here. And just in case they have reminded us of Newton's second law, which is mathematically F is equal to ma, where the resultant force equals total mass times resulting acceleration. So let us analyze the system that has been given here. There are two masses, m1 and m2. They are side by side, and there is a force F acting on m1. And for the sake of simplicity, let us say that this surface has no frictional forces. So if the masses move on the surface, there's not going to be any opposition to it. There's not going to be any frictional forces. So let us start solving the problem. Now, when we try to solve problems in physics, the first thing that we do is draw a diagram. In this case, the diagrams have a special name. They are called isolation diagrams. So what these diagrams help us to do is to simplify the system that we have been given here. So in this case, the system has two masses. Now, what is simpler than a system with two masses? Well, there is a system with just one mass, right? So let us draw a system. Let us reduce the given system into a system with just one mass. And we can do that by just putting one point in here, right? So there we go. That is our 1 point, and that 1 point represents the two masses that we had. So this is going to be m1 plus m2, right? So the single point represent both the masses. Now, why is it okay to represent these blocks by just a point? That is because these blocks are not going to explode or blow into pieces due to the action of this force. They're going to stay together. They're just going to move. And every single point on mass m1 and mass m2 are going to have the same acceleration. So since all the points have the same acceleration, we can just consider 1 point and consider what happens when the force applied on that 1 point. So with that, we've drawn the diagram. We have simplified a problem with two masses into a problem with just one mass. Okay, so what next? We'll add details to this system. We'll draw the forces acting on it, and as is clear from the figure, there is a force F acting on the system. So let's draw that force. So this is our force F. Alright, now we need to get a little bit more creative because there are more forces here, and we need to identify what other forces are there, because if we miss any of the forces, our answer is going to might be wrong. So again, as we mentioned earlier, there are no frictional forces. So note that this block has not sunk into the surface. Like it's staying on top of the surface, which means that this surface is exerting some force on m1, and it is keeping the mass on top of the surface, right? So that force is called the contact force, and the contact force is normal to the surface. So there we go. That is one of the forces acting on the system. So let's draw that. That is our normal contact force. We denote it with the symbol N. And are there any other forces? Of course, there is the force of gravity. Now, don't forget the gravitational force. It is easy to forget gravitational force actually, because when you see the surface, you'll probably remember the normal contact force and the frictional force, if there is one. But nobody is going to draw a picture of Earth below your question. So you might forget gravity, but you shouldn't. Remember not to forget gravitational force. So with that, we have drawn all of the forces that is acting on our system here. So what is left to do is what the question has asked us to do, which is to write the force equations. So let us do that. Let's write the force equations. So note that there are two directions here, the horizontal and vertical directions. So we need to write a force equations, one force equation for each direction. So in the horizontal direction, there is just one force, which is capital F, and because of this force, the mass m1 plus m2 moves with acceleration a. So we have taken Newton's second law and have applied it here. Now, how will Newton's second law look in the vertical direction? Well, in the vertical direction, we're going to have n minus fg equals m1 plus m2 times 0, because there is no acceleration in the vertical direction. These masses are not going to move above or below. They're only going to move to the right. So they have acceleration only in the horizontal direction. They don't have any acceleration in the vertical direction, and hence that is 0 here. So we have what we actually have here is n minus fg equals 0, or n equals fg. So basically the normal contact force and the gravitational forces just cancel out each other. So there we have it. Those are the force equation for this system. Now let's say that they don't ask the force equations for this entire system, but only for the mass m1 over here. What do we do then? Well, in that case, the question has given us a problem with just one system. So we can just put a point, we can draw a point for m1 alone, right? This is a point for m1 alone, m1, and we can draw the forces on m1. So what are the forces on m1? Clearly the force capital F, as it is given in the problem, and as we discussed before, there is a normal force. So this is capital F, this is our normal contact force, and of course never forget the force of gravity. And finally, remember, because of this force F, mass m1 moves, and mass m2, since it is in the way of m1, m1 pushes on m2, right? Now if you remember Newton's third law, for every action force there is going to be a reaction force in the equal which is going to be equal in magnitude to the action and is opposite in its direction. So because m1 is going to push on m2, m2 is going to push back on m1. So we need to draw that also. So this is F21, force exerted by mass m2 on m1. So that is the diagram for mass m1 alone. We can draw a similar diagram for mass m2 alone, but I'll leave it to you. So here you go. The first thing we did is draw isolation diagrams for necessary masses, by which I mean when they asked for the entire system, we drew one point that represented both the masses here, that is m1 plus m2. But when the question was to answer only for mass m1, we drew just one point and drew the isolation diagram for that. So draw the isolation diagram for the necessary masses. And the second step, draw all the forces. Remember not to forget gravity. Okay, draw all the forces. And the third was write the force equations. Use Newton's second law and write the force equations. I hope this video helped you. Thank you.